This is Math 97, Quiz 3 topics. Identifying direct and inverse variation from ordered pairs and writing equations. First, let's review what direct variation and inverse variation are. Direct variation is when y is some constant multiple of x. And so this constant of variation is the ratio between y and x. So whatever pair of x and y you have, if you divide them, you will get a constant for direct variation. For inverse variation, y is some constant divided by x. And so if you notice, if we would solve this equation for the k, we would now have that constant of variation is the product of x and y. A constant product. Okay, and so let's take a look at our examples and see if we can identify each of these types of variation. It says determine whether each table shows a direct variation, an inverse variation, or neither. Write the equation for direct variation or inverse variation if it exists. So we'll look first at table number 1. We have these three ordered pairs, 2, 7, 4, 14, and 10, 35. So let's start by checking if these represent a direct variation equation. We can do that by doing each pair and seeing what y over x would be equal to. So in the first one we'd have 7 over 2 is our y over x, which when we divide we'd get 3.5. The second one would be 14 over 4, and when we divide that, we get 3.5 again. This looks promising. And then the third one would be the y, so 35 over the x, 10, and 35 divided by 10 is also 3.5. Since all three of these y to x ratios were the same, they were constant, that means that this was a direct variation equation, and our constant of variation was 3.5. And so we know that k equals 3.5, and so we'll say this is direct variation. And our equation then would be y equals 3.5x. All right, let's look at a second example. Our second table has pairs 2, 21, 4, 31.5, and 6, 7. So again, let's start by trying y over x in each case and seeing if that is a constant. So the first one, 21 divided by 2 would be 10.5. In the second one, 31.5 divided by 4 would be 7.85 or 875. Now, obviously that's different, and so that means that this cannot be direct variation since these are different. So we know that it's not direct variation. However, it could be inverse variation. So now let's try instead the product of each of these pairs, x and y. So 2 times 21 would be 42, and then 4 times 31.5 would be 126. Oh, those are different, and so right away we know that this cannot be inverse variation. And so this table is an example of neither of those. So that's our answer, that it's neither direct nor inverse variation. Okay, finally, our third example is this table. And so our ordered pairs are -3, 24, 6, -12, and 8, -9. So again, we check first whether this is direct variation by seeing if we have a constant ratio between y and x. So the first pair would be 24 over -3. That would be -8. And then the second pair would be -12 over 6. that would be -2. Okay, right away we can tell that those are different. So this one is not direct variation. Okay, so let's go ahead and try now inverse variation. See if we have a constant here, product of x and y. So x times y in the first pair would be -72. In the second pair, 6 times -12 is -72. And in the third pair, 8 times -9 is also -72. So we have an inverse variation example because the product of the x and y in each pair was the same. So here our constant of variation is -72, and we can write our equation. So we should say this is inverse variation. And our equation would be y equals -72 divided by x.